Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on single phase full bridge inverter with R load and L load. So now here the classification of inverters. First, the types of inverters. First one is the voltage source inverter and second one is the current source inverter. And next single phase off bridge and full bridge, and in the three phase inverter. So we have two types of inverters: 180 degrees conduction mode inverter and next 120 degrees conduction mode inverter. In the voltage source type of inverter, so here the voltage is constant, output voltage is constant irrespective of load, means independent of load, whether it is R load, L load, RL load, RLC type of load. For all loads, output voltage is constant. So that is a square wave. And in case of current source inverter, there is a output current is constant independent of load. Now here in the single phase, here you will get the single phase voltage, and here in the three phase you will get the three phase output voltage. Single phase off bridge, here we will use two switches we will use. Here in the full bridge we will use 4 switches we will use. So now here today we are going to have a discussion on single phase full bridge inverter with R load and L load only. So now here this is the circuit diagram of single phase full bridge inverter with R load. So this is the R load. Here we are using 4 switches. So 4 switches means here the switches may be here one diode. Here the diode is connected in anti-parallel with the switch. Here 4 switches means S1, S2 and S3 and S4. Same fashion D1, D2 and D3 and D4. S1, S2 are connected in anti-parallel and S4 and D4 are connected in anti-parallel, and S3 and D3 are connected in anti-parallel, and S2 and D2 are connected in anti-parallel. So why diodes here? In the inductive type of load, pure L and pure RL circuits, so the diode will active. So that I will explain in the next slide. In the single phase full bridge inverter with R load, RL type of load, that I will explain. So here this is the R load, and same fashion V by 2 and V by 2. In the single phase off bridge inverter we have only 2 legs S1 and S2, but here we have 4 switches S1, S2, S3 and S4. So the notation is S1, S2 and S3 and S4. Now here so S1 and S2 will conduct. S1 and S2 will conduct from 0 to T by 2 duration, and S3 and S4 will conduct from T by 2 to T duration. Total time period is T. Off duration S1 and S2 will conduct, and remaining off duration the S3 and S4 thyristors will conduct. So in the first off duration from 0 to T by 2 duration, from 0 to T by 2 duration, so apply KVL in this loop. So now here S1 and S2 thyristors will conduct through, this is the circuit diagram. This is the circuit diagram. So S1 and S2 through R load. This is the circuit diagram. S1 and S2 thyristors will conduct during off cycle T1 and T2. So in this case, if you apply KVL in this loop, so minus VDC by 2 minus V0 plus is equals to 0. So this is the case. Here output voltage equals to this, output voltage equals to VDC by 2, this VDC by 2. And next case here minus VDC by 2 plus again minus VDC by 2. So now this is VDC only. Minus VDC by 2 plus minus VDC by 2. Here minus VDC by 2 minus V0 and again minus V0. So that is VDC by 2. And next in the second half cycle, so here this in this case, so V0 equals to VDC only. So now again in the second half cycle, let me change the color over here. So here is the this is the here in the second half cycle, S3 and S4 thyristors will conduct. So this is the S3, it will connected like this. So this is the case. So now here in this case, so same way here minus VDC by 2 here. So plus V0. So if you apply KVL here, minus VDC by 2, minus VDC by 2, again minus V0 equals 0. Here is also V0 equals to VDC only. So now here 0 to T by 2, here 0 to T by 2 to T duration, here S3 and S3 and S4 switches will conduct through this R load. And next here from 0 to T by 2, this red color, so S1 and S2 switches will conduct through this R load only. And next here, if you see the waveforms, so first is the output voltage waveform, and next current waveform, output current waveform, switch currents, and next here diode currents. Here there is no diode is conducting here, so the diode current is always 0. Here no diode, none of the diode will conduct in all the cases 0 to T by 2 and T by 2 to T. 0 to T, the diode current is 0. So now here D1, D2, D3, D4 diodes will not conduct. First if you see the output voltage, here output voltage, so here 0 to T by 2 V0 equals to VDC, and next from T by 2 to T, and next V0 equals to minus VDC. Here the switches will conduct, S1, S2 will conduct from 0 to T by 2. You see the time duration 0 to T, so this is the T, and off period is a T by 2, T by 4 and 3T by 4. So now here 0 to T by 2 up to this period. So which thyristors will conduct? S1 and S2 thyristors will conduct, and next here in the second half cycle, S2 and S3 and S4 thyristors will conduct from T by 2 to T4 duration. So what is your output? So this output voltage equals to, so now here this is VDC plus VDC and this is a minus VDC. So this voltage is VDC and this voltage is a minus VDC. So now here this is a VDC and this is a minus VDC, 0 to T by 2, that is minus VDC. S3 and S4 switches will conduct. Here from 0 to T by 2, S1 and S2 switches will conduct, that is VDC. And next here, what about the output current? So this is the R load, means voltage tip type of load. It will follow the output voltage without any deviation. It will follow. So whatever the output voltage, the output current is also same shape here. This is the output voltage. So now here I0 equals to V0 by R. So here we are dividing the output voltage with respect to R upon R, means here output voltage is always greater than output current. So now here this is the output voltage and output current. This is the V0 by R. VDC by R we can write here. So now here this is the V0. And now next, what about the switch current? Switch current is also same. Here during a half cycle, only one switch, these two switches will conduct. S1 and S2 switches will conduct. S1 switch, I am talking about one switch only. S1 switch current only, and S2 switch current is also same. Now here what about the S3 switch, means S3 switch current means here this one current, this one. So this current is up to here. And S4 switch, S1 switch current. Here S1 switch current is, I am talking about S1 switch current means only positive off cycle, positive 0 to T by 2 only S1 switch will conduct, and S1 will not conduct T by 2 to T. Same way here S2 also same, 0 to T by 2 only S2 will conduct, and from T by 2 to T S2 will not conduct. Same way here S3 switch will conduct from T by 2 to T only. From 0 to T by 2 S3 will be off. And next, same fashion S4 also. 0 to T by 2 T only S4 will conduct, and 0 to T by 2 S4 will not conduct. So diode currents all are 0. And now here this is the I0, and now this is the output voltage. And now here, what about the fundamental component of current? So fundamental component of voltage. Let me change the color over here. So this is the fundamental component of current, means here this is the fundamental component of voltage, means any square wave. Any square wave, this is the square wave. Any square wave is resolved into series of sine wave with different frequencies. This is fundamental. So this is the V01 maximum. This waveform is the V01 of T, fundamental component of voltage. So this V01 maximum, fundamental component of voltage maximum, is always greater than this output voltage maximum value VDC. And next, here is also same, this fundamental component of current, output current. So this is V0, not V01, I01 maximum. So this is the case I01 of T. And next, fundamental component of switch current, it will conduct only up to this one, IS01. So switch 1 current, so that is the maximum value. Always this peak value of fundamental voltage, output current, switch currents are always greater than this total output voltage, output current, and output switch currents. So now here this one is also same, and this diode current is 0. So these are the waveforms related to single phase full bridge inverter with R load only. Now here let us take the RMS output voltage. So how you will calculate the RMS output voltage? Any square waveform, this average value is 0. This is a symmetrical waveform. Symmetrical T by 2, first positive half and negative half is same, means that is symmetrical waveform. Average value is 0. So here for all loads average value, but here RMS value is not 0. Here how we will calculate the RMS value? So there is a formula, in that also you can calculate. So first one is here 1 by T under root integral of 0 to T and V0 of T. So here V0 equals to what is a V0 equals to VDC only. So here V0 is, the first one is, it is divided into 0 to T by 2 and T by 2 to T. This is VDC plus, and this is the minus VDC dt, and this is 1 by T. So this is the case. But here if you do this, you will get the output voltage is VDC. V0 or RMS output voltage is 0. In another way also we can calculate this RMS output voltage. Square the waveform. So this one. So here this is square the waveform, means here VDC and VDC, and take the average. You will get the average is same VDC, and after that take under root. So that is also same VDC only. V0 RMS equals to VDC. And next here, what about the fundamental output voltage? So this output voltage, this square waveform output voltage, Fourier series equation is n equals to 1 sigma of n equals to 135 n 4 into VDC Vs divided by n into sine omega naught. This is Vs. Actually this Vs equals to output voltage equals to VDC. So now here, what about the fundamental component of output voltage? What about how we will draw the fundamental component output voltage? So now here I am drawing the, so this is the fundamental component of output voltage. So this one. So this is the V01 maximum. So now here V01 maximum, this is the V01 of T, fundamental component. First, this frequency n equals to 1. Substitute in this n equals to 1 and this n equals to 1. So 4 VDC by pi and n, this n equals to 1 sine omega, this n equals to omega t. And next here, second one is maximum value of V01 maximum. So first, this is a V01 maximum. And next I01 maximum, here this one is also same. This one V01 maximum means same. This is I01 maximum. So for the V01 of T divided by R equals to I01 of this one. And next here this is also same. So now this is the maximum value. Now here what about this V01 maximum? This is a V01 maximum. This is a I01 maximum. So now here V01 maximum, this is a V01 maximum equals to 4 VDC divided by pi, and this one equals to 4 VDC by pi into R. And now here how we will calculate the RMS value? RMS value equals to always for any sine wave, so Vm by root 2. So RMS value of this one equals to Vm by root 2. So now here, so that equals to 4 VDC by 4 VDC divided by pi R, pi into pi by root 2 means this value equals to 2 root 2 VDC by pi. So that is fundamental component of voltage RMS value equals to 2 root 2 VDC by pi. And next here, fundamental component of output current. So this is one maximum value, V maximum, this equals to Vm I01 maximum divided by root 2. So that equals to I01 maximum means this one equals to 4 VDC by pi by root 2, that equals to 2 root 2 VDC by pi R. This is pi R. So now we have 4 formulas. V0 total output RMS voltage equals to VDC, and output current, output voltage Fourier series equation equals to sigma n equals to 135 n 4 VDC by n pi sin omega t, and V01 equals to fundamental component of voltage equals to VDC by pi sin omega t, and I01 equals to, this one is also sin omega t, 4 VDC pi by R sin omega t, and fundamental component of voltage RMS voltage equals to 2 root 2 by pi VDC, and fundamental component of RMS value equals 2 root 2 by pi R VDC. And next here, distortion factor equals to V01 RMS divided by total output voltage, that equals to 2 root 2 by pi VDC by VDC. VDC gets cancelled. Here finally you will get 2 root 2 by pi. And next, what about the total harmonic distortion? Total harmonic distortion equals to, that equals to THD equals to square root of 1 by G square minus 1. So G is the distortion factor. So here if you substitute this value in this, so you will get the 48.34 is your answer. Your 48.34 is your answer. Total harmonic distortion for single phase off bridge inverter for R load is the 48.34. And now these are the first formula, second formula, third, fourth, fifth, sixth, seventh, and eighth. And next here, switch current. So here switch current is also, this is a switch current. So this current is also same. And now average source current and average, let me change the color over here. Average switch current, here average switch current is, this is a switch current, this is a total time period is equal to, this is I naught. So now here IS average equals to, so I naught into total conduction time is up to T by 2 only, and total time period. So that equals to I naught by 2 only, IS average value. This is the IS average value. And next, RMS value, how we will calculate? IS RMS equals to, that equals to I naught into root 2 by IT by T. So that is the case here, I naught into I naught by root 2. This is the case here. This is the I naught. I switch RMS or source RMS current equals to I naught by root 2. And next here, what about fundamental average switch current? How we will calculate this one? That one equals to IS01 average value. Here we are getting, so this switch current is, here we are getting half waves rectifier output. Here is also half wave rectifier, any output voltage equals to I maximum divided by pi. So that is our average value equals to, whatever is RMS value equals to, RMS value equals to I maximum by, here I maximum by 2. So here this is the fundamental component of switch current, and here fundamental, this is the I01 maximum, this maximum by pi. I will calculate this I01 maximum. So what is the value of I01 maximum? Already we have calculated this I01 for VDC by pi into R. This is the fundamental component of current maximum value. So substitute in this, you will get the fundamental average switch current and fundamental RMS switch current. And next here, total power across load due to fundamental. So this is the formula. So total power equals to V01 RMS and I01 RMS cos phi. So that is equals same. So here cos phi equals to, what is the cos phi? Cosine angle between. So cosine angle between voltage and current is 0. Here the voltage starts from here same, and next both are voltage tip side top load. There is no angle deviation there. Without any deviation, output current follows the output voltage. So that cosine angle between voltage and current, that value is 0. This cos phi is 0 means this value is cos 0 is the 1. And next here, total power across the load due to the fundamental is that V01 RMS and I01 RMS. And now here V01 RMS, what is the value of V01 RMS and I01 RMS? V01 RMS is 2 root 2 VDC by pi, and this one is the 2 root 2 VDC by pi into R. So now multiply these two. So 2 root 2 whole square is the 8 VDC whole square, and next to pi square into R. This is the final output power across the load due to fundamental. And next, fundamental power delivered by each source. So that is here P01. So this is source current, source voltage, that is VDC by 2. Here there is a VDC by 2 and VDC by 2. And this is the average switch current into 2. Average switch current into 2. So now VDC by 2, average switch current equals to I01 maximum divided by pi. I01 maximum means VDC, 4 VDC by pi R into 2. So finally you will get the 4 VDC square by pi square into R. So this is for each switch. So multiply with 2 means here you will get the same value. And next, total power across the load. So how you will calculate the total power across load? So P0 equals to not fundamental. This one indicates the fundamental. And total power V0 RMS, I0 RMS into cos phi. So V0, this cos phi is 1, phi value is 0. And that equals to V01 RMS, I01 RMS. So that equals to VDC square by. So this is a VDC and this is a VDC by R. So now here this one is a power output equals to VDC square by R. Total power delivered by each source means here total power delivered by the source, each source VDC by 2 into IS average, not fundamental. So this into 2. So that IS average equals to I0 by 2. And next here this I naught means V naught by R. V naught means here VDC. So that is VDC by 2. If you multiply with 2, so here you will get the same. And next here, second one is a single phase off bridge inverter with L load. Here in the L load, here we are changing the load only. So whatever the load you take, so you will get the same output voltage, but here current only changing. Here what is the current value? Current is a triangular, but in case of R load, that is a square wave. Same type of waveforms like single phase off bridge inverter with R load, L load, RL load, RLC type of load. But here the output voltage VDC by 2 for the half bridge inverter and VDC for full bridge inverter. That is only change. So that I will explain from 0 to T by 2. So this is minus VDC by 2, minus VDC by 2 plus V naught. So this is a VDC by 2, S1 and through L load, and next S2 and next VDC by 2. Here this 2 thyristors will conduct, and next here 0, this output voltage equals to VDC only. And next what about this is for L load, and next here minus VDC by 2, minus VDC by 2, 0 to T by 2 only, 0 to T by 2 and T by 2 to T duration. So now here, so this value is minus VDC by 2. So in this case, let me change the color over here. So here let me take this color. So this color here through L load, S3 and S4 thyristors will conduct. So now here if you see the switches configuration, D1, D2, when D1, D2 will conduct and D3 and D4 will conduct. So here what is the property of inductance? Inductor is a passive element which stores the energy, which receives the power from the sources and stores the energy in the form of magnetic field, and it delivers to the load. And during 0 to, here let me change the color over here. So here 0 to T by 2 duration. So here that I will explain. So when S1 will positive, S1, S2, D1, D2 will conduct, when D1, D2 will conduct. So when a power is delivered from the load to the source, so that is the case, D1, D2 will conduct. And next that I will explain. First from the waveforms only I will explain. So these are the output voltage V naught, output voltage, output current, switch current and diode current. So here output voltage is from 0 to T by 2. So the output voltage is T by 2, from the 0 to T by 2. T1 thyristors, S1 and S2 thyristors will conduct, switches will conduct, and in this case S3 and S4 switches will conduct. But here any DC excitation is given to pure inductive. So here you will get the output current is the output current is the triangular waveform. For if any excitation is given to the pure R load, so you will get the same type of waveform, that is square wave. But here you are getting the triangular waveform. So this voltage is output voltage, here triangular waveform. Here when S1 will be positive and S2 will be when V naught is positive, when I naught is positive. So that I will explain. So first here during D1, D2, during S1 and S2 will positive. So here S1 will conduct. So this is a positive voltage, but here the current is opposite to this one. So the current is opposite to this one, means this is the, so here, so let me change. So here this is the current direction. So here this is the S1, S2, this one. These are. So now here S1, S2 thyristors will conduct. Here D1, here S1 and S2 thyristors will conduct. So V naught is a 0 positive and I naught is a negative. Sorry, this one here S1 and S2 will conduct. So from 0 to from 0 to t by 2 duration. So here voltage is positive and current is a positive, both are positive. And next here D1 and D2 will conduct. So here D1 and D2 will conduct during 0 to t by 4. This is the t by 2, sorry, this is t by 2, t by 4 duration to t by 2 duration, but here 0 to t by 4 duration, D1 and D2 diodes will conduct. So these two diodes will conduct. These diodes will deliver the power from source to the load to the source, and here positive, negative and positive. So negative voltage is negative and this one is a positive, means here D1 and D2 switches will conduct. So here T by 2 to and 3T by 4. So D3 and D4 switches will conduct. And next here during this period 3T by 4 to T duration. So S3 and S4 switches will conduct. Both current and voltages are negative. So now here if you take the output voltage, so fundamental component of output voltage is same as the R load, but here this is the I01 maximum and this is the V01 maximum, V01 of T. This one is a I01 of T. So now here if you see the comparison here, output voltage, fundamental component of output voltage maximum value is greater than this total output voltage maximum value, but in case of current, so here fundamental component of output current is maximum value is less than this total output current. So keep it in mind. So in case of resistive load, that is a greater than, but here is the less than value. This is the case current, voltage and current waveform. And next switch currents. So this is the I01 max. And next these are the S1. These are S1 current, and next here S1 and S2 and S3 and S4 switches will conduct, and these are the diode currents. So D1, D2 and D3 and D4. But in case of pure RL load, so that diode current is 0. So these are the waveforms for output voltage, output current, fundamental component of output voltage, fundamental component of output current, and switch current. So switch currents, so let me change switch current, fundamental component currents are here. Let me change the color over here. So this one, and next here these are the fundamental component of switch current, IS01, IS1 of T. And next here, so these are the same output voltage RMS value equals to VDC. So that already we have discussed. Output voltage Fourier series equation for VDC by n pi sin omega t, sigma n is equals to 1, 3, 5 and n. I naught equals to here in previous case this pi value is 0. So both in the R load, so that whole cosine angle between voltage and current is 0. But here it is starting from 0, but here it starts at pi by 4. If it is 2 pi, here this is pi and this is pi by 2. So here I naught lags voltage by V naught by 90 degrees. So this is important. So here output waveform, output current waveforms lags output voltage waveform lags voltage by this 90 degrees. And now here I naught of T equals to, so VDC, and next this V0 of T by Z equals to I naught of T. This is the case. So here Z equals to omega L. So that is Z equals to R value is 0, means that is omega L, that equals to 2 pi of L. So that is omega L. So that is XL. So now here omega equals 2 pi. So now here final output current. So final output current equals to in Fourier series sigma n equals to 135 n. So 4 VDC by n pi by Z means that is omega L sine n omega t minus pi by 2. Here what, this is the phi value and this is a Z value. Here phi equals to pi by 2, here phi equals to Z. So now here fundamental component means substitute n equals to 1 for V0 of t and I0 of t. What is the conduction time for each switch? It is pi by 2 only. Diode D1 and D2 and S1 and S2. That is t by 2 duration only each switch will conduct. Total time, total conduction time is for that is pi only. So that is. So name same way, diode is also same. Each diode conduction time is pi by 2. Total conduction time for diode is the pi. And next IT average equals to, how we will calculate the IT average value. So this is the IT average value. This is the one. So now here IT 0 maximum value. Next here this is the T. What is the duration? T by 2 minus T by 4 means that is T by 4. And next here this is a maximum. How we will calculate this one? Half into B into H. Half into B value is T by 4. And next here I01 maximum divided by total time period is T. Here TT gets cancelled and your final is the I0 maximum divided by 8. And next here how we will calculate the IT RMS value. IT RMS value equals to total time period is 2 pi and next it is conducting from T by 0 to T by 2. So pi by 4 to pi by 2 by 2 pi and next here 4 into I naught maximum by pi the whole square into D. This is I0 of t, so that I will explain. So now here how I of t is you got it means here so here this is the case. So this is the case means here I0 I of I equals to L V equals to L di by dt. So now here this one equals to, so this I naught, so di by dt equals to change in current. How you will calculate the change in current? So change in current means here I naught maximum, this I of t equals to, how we will calculate 4 I naught by pi by 4. So this duration is a pi by 2 minus pi by 4 and next here is the I naught maximum value. So that equals to I4 into I naught maximum by pi. So now here this is the case for I of t by theta. So theta equals, this is the t. So t and t. So here your RMS output voltage is, so that is here this one. And next here fundamental displacement factor. Here the cosine angle between voltage and current is a 90. So that value is 0. Here I naught lags voltage by 90 degrees. So this is the case. And next this one, total power across the load. So this cos phi is 0 means, so this is 0 means total output power is 0. Same way here is also, this cos phi is 0 means this is 90. So this one is also 0. And fundamental average switch current. How we will calculate the fundamental average switch current equals to, this is the half wave rectifier output voltage for each switch. So I01 maximum by 2 pi. To conduction time is 2 pi. And next fundamental component RMS switch current equals to I0 01 by 2 root 2. And next here, I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.